Okay, so the purpose of this is to go through the training I've written previously, which was written in a way so that people can get an idea of how people that have a pre-existing Vault setup probably have it set up, and then what needs to be done to convert to the new way of doing things. If people are starting from scratch, the current documentation should get them going without any problems. So, but this, this gives you a handle on what they're likely going through. There are some prerequisites. You do need a working instance. Can everyone read this? Is it big enough?
Yes.
Yeah, perfect.
If you can't or have any questions, feel free to jump in. So you do need a working instance, which is accessible over HTTPS, somewhere to actually run Vault, and this needs to be accessible from your runner. GitLab itself doesn't need to talk to Vault, but the runner does. So from a firewalling point of view, you need to bear that in mind. You need a project, and you will need the project ID for that project, and at least a premium license in the namespace or on the instance. You can use GitLab.com for this. It works fine. Subject to the runner being able to talk to Vault. There are a couple of ways of installing Vault. They release pre-compiled binaries, which is useful for things like this. There is a Docker container, and a lot of distributions do have their own packages as well. We're not going to go into setting up Vault properly because it's quite involved. You need certificates. It generates lots of passwords. The idea being that no one person can decrypt the secret store. So when it starts up, if you've got it configured properly, you need several people to log in and put their password in to unlock all your corporate secrets. So we will be running it in a developer mode, which doesn't need that. I've already gone through these steps to download it and extract it and install it. So we can see that it's installed here on what is my runner instance, thus getting around the communications problem that you may have. Running Vault as a server is pretty simple. You run the Vault command to tell it you want to run a server. For us, we want to run it in developer mode, and if you don't specify this particularly, it will listen on loopback, which will cause you communications problems. So just for the sake of testing, we'll get it to listen on all interfaces. And Vault has two different versions of its key value store, version 1 and version 2. The commands we're running in the training don't change as a result of this. How you talk to it from GitLab CI/CD does change as a result of this. And I'm not 100%, and I couldn't find out when they introduced version 2. But if you already were running Vault with version 1 of the key store and you upgrade Vault, it doesn't upgrade the key store. You have to manually upgrade the key store when you choose to do it. So given this training was designed around people running old versions moving forward, we're going to force ourselves to version 1 this. If you don't specify this in developer mode, it will force you onto a version 2 key store. So we can just paste that in here and it will start. Some key things to note, just really from this training point of view, just double check that it is listening on everything like we asked it to, and that TLS is disabled. So we should be good on that front. We will need to do this, and I will demonstrate why in a second. So So first thing we need to do now we've got Vault running is to put some actual secrets into it. The syntax of a lot of these commands is similar as we go through this. So on Vault, first thing we do is tell it we want to talk to some key value storage, and we want to put a secret into the Vault. This first bit of the path is a object inside Vault that has been defined as a key value store. You can create other ones with different names, but then you need to go through the procedure of setting up access lists, etc., for the user to be able to access them. It's a bit out of scope for this. So what you put after this can be anything you like. So for the sake of this, this is the same as the project that I've got in GitLab for this. And then as an example, as an environment name, and then the application in that environment that this secret's for. And then inside this object here, you can specify one or more fields to store in that object to be accessible later. So we will. So this is what happens if you haven't done the export of the Vault address. So by default, it will assume you're running on HTTPS because you wouldn't keep their secrets behind HTTPS. But because this is just training in an example, we will override that setting and put the secret in again. And we get
Simon, may I ask a question about that?
Yeah, sure.
Do you know if they advise against automating that with, for instance, your bash RC or your profile, the export for security reasons, or do you or not?
Well, it defaults to, if this isn't set, it will use the default, which is localhost and this port. So
Okay,
you wouldn't, if you were running defaults, you wouldn't need to set it at all. If you're accessing it from your local workstation, then you would need to set it. And at that point, you are doing authentication as well because you're not local. So it would be fine to set in your environment because you would still need to log into it.
thank you.
So we'll set 2 secrets so we can demonstrate access control a bit later on. So we can see that they were written because we get a success message. If you're running version 2 of the key value store, you do get a change history. So when you run this command, it will give you the revision number and some other information. But we don't see that here because the version we're running. You can also then retrieve those secrets as an admin user or a user with the right permissions just to verify they've been saved properly. So this is similar to the put command. It's just we're retrieving, so we're using get to get from the storage. And a little frustratingly from my point of view, you have to put the field flag here and then the path afterwards. You can't do those the other way around, which caught me out a few times, but yeah. Okay, so between your secrets and the client connection, there are two more things we need to set up. There are policies, which map capabilities, as they call them, but they are effectively permissions onto paths in your secrets. And then there are roles, which incoming client connections specify the role they want to connect as. That's verified. Then that role tells Vault which policy that connection is allowed to use to access secrets. There is a lot more detail on the different capabilities and things that you can specify in the Vault documentation. Specifically, there are these capabilities. So you could have a CI job that updates them if it needs to, depending on your environment, SSL certificates, stuff like that, because you can store files in here as well, or convert files to strings to store. So if your environment needed it, when you put things into the secret store, you could include the password, the username, any SSL certificates that are required, just to keep them outside of your GitLab instance. So we can just copy and paste these. So this is a JSON object. Suspect we all recognize those by now. But it does also, which is quite neat, it retains the comment as well. So you could use this for documentation and changing, etc. But as I stated earlier, there's no change history in the version 1 of the key safe. So once this is overwritten, you will lose any previous comments unless you're maintaining them. But we can see that both of these written in the staging one only includes the staging path, and the production one only includes the production path. Excuse me. Okay. So the next step is configuring the authentication roles. Before we do that, we do need to turn on Java Web Token authentication, which is what CI uses to talk to the vault. So let's turn that on. And then we need to write the configuration information for that. So for the old style way of accessing Vault, it's this version of the command. So we're writing to the JWT authentication path, the configuration. This URL has to be HTTPS, and Vault will go off, talk to your instance, negotiate a signing key for communication, and save that into Vault. And bound issuer, this is free text, but it is specified by the client when it connects, and it needs to match, because this is then used to match this to then verify that the token is correct when the client connects. And this is actually one of the first stumbling blocks customers will bump into when they try and convert to the new version. But we'll get to that later. I have the pre-written one for the test instance. So we got a success. So we can assume that that's configured correctly. Authentication roles are quite cool, actually. So again, we're running the Vault command and we are writing to the key. Auth, again, is fixed. And we write to JWT, a role, and this is the role name, which we will need later. This can be any alphanumeric hyphen you like. And again, we're into another JSON object. So we're telling Vault that it's a JWT token role. This is a list. It can be a list of policies that you want this role to be able to access. So these are the same as what we specified in the last step up here. So that's how these two things are tied together. How long we want the token to last for. You don't want that too high in case the token gets stolen, although there are rebinding protections. This is informational for logging. And then this section here is where the fun starts. So there are a list of fields that GitLab includes in the token. And you can then match on these in Vault to define the access for that token. So in this particular example, we would only allow CI jobs running from projects with the ID 26 on the main branch. So anything else connecting and trying to use this role will fail to connect because it won't match this information. And for the production example, we turn on glob matching, and then we are specifying additionally that we only want protected branches that match this pattern to be able to talk to the production policy and thus the production secrets. So you can use this to, because your staging secrets, you won't care as much about likely as your production secrets. So you can use protected branches similarly as you would do with GitLab CI/CD secrets to protect the more important keys for your environment. Yeah, sure, go ahead.
So what I understand, this is a security measure, but how is this different from CI/CD environment variables? Like when do we use Vault versus like CI/CD?
That's an institutional decision, to be honest with you. This does kind of give you a bit more separation. Some companies may already have Vault. They are very similar. Is there a limit on how many CI/CD variables?
I think it's really just that at a certain organization size, our current capabilities for managing secrets within GitLab doesn't really scale anymore. We are improving that, and secrets management within GitLab is a topic that we are actively developing this year, as far as I'm aware as well. But traditionally, it has just been the fact that Vault is a product suited for exactly that job. Like if you really have, I don't know, 500 teams and 30,000 projects, you need something that's really capable of doing proper secrets management, which at that size, we just weren't. Like imagine all the hierarchy of inherited variables and stuff, it just becomes unmanageable. And Vault is better suited, and that's why allowing Vault access from CI/CD was a pretty good solution to combine those two things.
It's just to add to what you're saying, Manu, it also lives in the microservice and the API service space very, very comfortably. It's designed to fit into that area where you never at any point do you have any two or more items required for authentication in one place. It's all like, about a sequence of calls. Anyway.
Yeah, I mean, and also if you have other services that need to access these secrets, if you had them in CI/CD variables and in Vault, you put them in two places, so you're tracking more information in more places. And you can give the client connection to this doesn't have to be CI/CD. This could be a manager or a person in an environment, in a department. So you could give different access to different members of staff so they can manage secrets in one place, whereas CI/CD variables are all or nothing. If you've got access to those variables, you've got access to all of them. There's no granular filtering at the moment in GitLab.
Exactly. Yeah, like there was one. This is exactly why I joined this session. To be honest, there was one use case I came across from one customer. They had like one job that was responsible for provisioning, for deploying the project like in a server or something, and they wanted to make sure that each user, like they wanted to separate access per user, and they were not able to do it using the same CI job. So I think, yeah, they pivoted I think I suggested, or they pivoted to Vault just because of that, because they wanted to, oh, this is user X, so this is the credential you have access to. Oh, you're user Y, okay, so you have access. Yeah, so they were not able to do that in CI/CD, but yeah, the option was there with Vault.
Yeah, that makes sense. Okay, so yes, we set up our JWT, so we need to now configure these roles. I'm going to use similar ones, but the project I've set up for this has a project ID of 1, so I need to change this, but have some I prepared earlier. And so similarly, this is the same as what's in the training doc, except for the project ID, but we get a success on each, so we know it's been written and we can authenticate from that. Just a quick look at the documentation on this. There are lots of different things you can filter on, so you can restrict to the namespace based on ID or path, project ID, path, username. Some of these are less useful from a security point of view. But yeah, we've got references, whether it's protected or not, in the environment and deployed tiers as well. So there's quite a lot of scope there to restrict secrets depending on the requirements.
Just to clarify how things work together here. So in this role definition, the user claim field, the bound claims field, the bound claims type field, these three attribute names, these are from the Vault product, right? That is something you can use to configure Vault.
Yeah, so these are things that
And
defined.
then within the bound claims thing, that is just a key value list that you can provide completely custom, and Vault will parse that and use it, basically.
Yeah, so the values here inside this list match up with what is sent by whatever.
Yeah, but I could, like, if I wasn't intending to use it with GitLab CI, like just looking at it from the Vault side of things, I provide a list here, and key and value are completely free for me to define. I will define it in a way that makes sense for whatever then I will use to send the actual JWT authentication claims. And
yes,
so the fact that we are using project_ID and ref_protected, that's because of an implementation detail on the GitLab side of things with the secrets and ID token keyword and everything, because that's some of the keywords that you just showed on the documentation page that we will send, right?
Yeah, so everything inside the bound claims is customizable based on, if you were writing your own client in your own environment, you would specify whatever you wanted to in here. Because it's written into the JavaScript token and then signed and optionally encrypted before it's sent. So it's verified by Vault based on the information that was negotiated here. So yeah, if you were writing your own product, you would likely have different things in here to do the verification against.
Yep, perfect.
Okay, so we're now at the point where we can just about write some actual CI. The one thing to know here is prior to GitLab version 16, there was a toggle option in settings CI/CD token access, which allowed you to switch between the method we're about to use and the new method on a per project basis. So that meant if you were looking to convert things, you would have to do it a whole project at a time, because once you switch this, the version we're about to set up doesn't work. GitLab 16 onwards, this toggle goes away and it actually detects the presence of ID tokens in an individual job. So once you're on version 16 or higher, you can actually do this conversion process on a per job basis, because if you've got ID tokens, which is the new method we'll get onto later, you won't get the old token and vice versa. And my test instance is higher than 16, so we don't need to worry about that switch box. So this is a very basic CI that will obtain one of the secrets we set up earlier. You've got a variable to set the host name of your Vault. You will need to set a variable with the role that you want to authenticate against. And the rest of this is from the old tutorial that's disappeared from the documentation now, but we use the Vault command to write to the remote server to obtain the authentication token based on the role and the CI job JWT, which is defined by GitLab and the runner, which contains all the information we've discussed previously. And then we attempt to get both passwords that we defined earlier. So we head over to here, pipeline editor, slightly modified version to work with what we're doing. So this is the same as what we've just looked at. It's the vault address has changed. One thing I didn't cover is I've got some rules here to set up the auth role that we need later on. So if the commit ref matches the auto deploy pattern that we set before, it will talk to production. Otherwise, it will talk to staging. So we'll commit that and see whether this works. Did yesterday. So, okay, one thing to note with these is when you're testing this job will always pass because none of these commands return an exit code other than 0. So you do actually have to look into the job to see what's going on. So we can see that it successfully retrieved the staging password. But when it tried to talk to the production password, it got permission denied because we're on the main branch. We're not on a branch that matches the pattern we set up before. This project is pre-configured. Just to show you, it has a protected pattern already set up for auto deploy with some pretty lax rules for the sake of this, but in your actual environment, you would have this locked down to stop people putting things into their CI to extract the secrets and run away with them. So what we'll do is branch main. So auto deploy 1, which starts another pipeline. So this pipeline ran in auto deploy 1, and we can see that it couldn't get to the staging secret, but it could get to the production secret. So that all works, and we've demonstrated that the different permissions work. And so this is where a lot of customers would have been prior to the announcement of the change. The first thing that's different with, and this applies to the CI job JWT v2 tokens as well, but they're also going away. This command will look familiar. This is the new version, but the bound issuer has HTTPS prefixed on it. And this is important because as soon as we change this for our existing authentication path, sure, go ahead, Philip.
So sorry. The previous method that we tested, I think it's going away in 16.5, and this is the newer one, the one that you're now explaining.
Yeah, so yeah, what we've done up to now is set things up how a lot. This training is derived from a ticket I had where a customer was struggling to do this conversion. So we've got to the point now where what we've got set up is going away in 16.5, and we're now going to work to convert to support the new version without causing too much disruption. So yeah, so what I've seen customers do on tickets is they've gone to their Vault instance and ran this to update their existing setting. Because you're writing it to the same point as the one we ran earlier, it will break your authentication with an error message you've probably all seen. So here's one I prepared earlier. Just adds HTTPS to the bound issuer. If we flick back to the job we just ran and rerun it,
And the
Um,
version of the instance is 16.1.
It's higher than 16. I think it's latest.
Okay, I'm asking because I've noticed the runner version. I was somewhat confused.
This was deployed out of Sandbox Cloud, so I had noticed that before. That's interesting. I just deployed it at Sandbox Cloud, so I'm not sure what's going on there. But it does work. I tested it all yesterday. So because we've changed the bound issuer, what we already had set up is now broken with this. When it tries to authenticate, it gets the invalid issuer claim error message, which I see quite a lot on tickets around this. So at this point, you've now broken all of your Vault integration across your entire project's namespace, etc. So less than ideal. We can simply just write back to auth JWT config with the old bound issuer, and then this job will run again successfully. Well, they're in the background. I have faith. Yeah, there we go. It worked. So we can get around this by creating a second authentication path into Vault. You can do this with a lot of Vault's functionality. You can create, as I mentioned earlier, you can create a different secrets path, and you would use a similar syntax to this. So previously, when we turned on JWT, we simply ran Vault auth enable JWT. But what we can do is add this in here, which creates a different path into the authentication system, which does not break our existing infrastructure. So if we write that in here, it tells you that it's enabled it at a different path, which is great. And then we run a slightly modified version of the command we've run previously. So before it was, we wrote to auth JWT, and now we write to auth JWT v2. So we can write this, and this is the version with the HTTPS. And because we've written to v2, we run this same job again. It will succeed still because we haven't overwritten the default JWT authentication path. Success. The other thing you do have to do at this point is, those that are following along, when we wrote the roles, we wrote them into the authentication path. So we do need to rewrite our authentication roles. You don't need to redo the policies because the policies don't mention the role. So they just sort of sit in the middle between the secrets paths and the roles. So this is the same as we saw earlier. It just writes to the new authentication path we've just defined. And we had success for both of those. So the new secrets resolution happens internally to the runner. As you'll see from this old version, we were having to run Vault commands, etc., to get access to secrets, which means you need to ensure the Vault binary is in your runner image, etc., which is less than ideal. So what we have here, there's some variables. As with all variables, you can set these at a project, a namespace level, wherever you like, really. And as long as these don't collide with anything you've already set, you can set these at your root namespace and not worry about having to put them in all your CI jobs. Here you specify your ID tokens. You can you can have more than one of these. It's a bit out of scope of this, but you can specify more than one ID token variable here if you have more than one secret store that you want to access inside your job. I will leave that to the documentation to explain. We have the same rules as before to detect auto-deploy branches versus other branches. And in here, we set the role and the path. Previously, in the other examples, we just put the path in the command line. So we didn't need a variable for it unless you were looking to make this more dynamic. But with the new method, if this fails, and it's basically the first thing the CI job does, if this fails, it aborts the job. It won't carry on. So you can't just try and grab all the secrets you like. You have to be pretty specific here about which secrets you try and access. So when we're on staging role, we want to access the staging secret, and similarly with production. So the other thing you need to specify when you specified ID tokens is the secret setting. This is the name of the variable that the secret will be put into. If you're using version 2 of the Vault key value store, you don't need to specify this, but because it defaults to this. But because we are intentionally using the version 1 key store, we have to override this, and you do have to specify both items, otherwise it fails. At the moment, last time I checked, we only support Vault KBV1 and Vault KBV2. I don't know whether there's any need to support anything else, because there are third-party secret stores, and I suspect they just implement the same protocol as Vault does. We specify the field we want to access, which we specified earlier, and the path through to the engine to know where it needs to go for the secret. One other change in ID tokens / secrets is that the runner will write the secret to a file and then return the path to that file in the environment variable. So a lot of modern CLI tooling will allow you to specify the password as a file rather than the actual passwords to avoid leaking passwords on the command line, which is quite a nice touch in my opinion. But you can override that behavior by specifying file as false. And because we're looking to help the customer transition and their current CI likely relies on the password being in the environment variable, we specify this. Lastly, by default, these variables are masked in the logs, which is another nice touch. However, it makes debugging tricky. So for the sake of this, I am just echoing the password to a file and then attaching the file as an artifact so we can double check it's correct. You could also MD5 sum this or something, so you can then output the hash and compare that to a hash you've already generated rather than doing this if you were doing it with secrets you actually wanted to keep a secret. So let's set this up. I'm going to leave the other job in there. So this is the same as what we've just looked at, except it's set up for this test environment. So different path and a different audience token. And we're on main at the moment. Okay, so we can demonstrate here that both work still. And the original CI we wrote is still able to retrieve the secrets because it's talking to the original JWT auth path. And the new one. So as I said earlier, the secrets resolution happens basically right at the beginning. And if it fails here, it will abort the entire job. But we move forward and you don't see all the output you see in the original jobs, but we can see my echo and we can see the artifact upload. And if we browse the artifacts, we can see our super secret staging password in plain text. So we know that on the main branch, the correct secret was retrieved. So it's just a new branch from main. Again, the original job is still working because we're on a deploy branch. See our production password and in the ID tokens, similarly, we did an error, so it authenticated all right. Then was able to retrieve something, and it wrote it to an artifact. So let's check. Yes, we have our production password. So we have successfully, for this particular project or particular job, managed to convert to using the new method. As I mentioned earlier, if you are running pre-16, you would have to be going into settings, the OCD, token access. We can't see it here because of the version of this instance, but there would be that toggle I mentioned here that you would have to switch between the two. And when you switch that, only one of these two jobs would succeed. But because of the change that was implemented in 16, that it's done on a per job basis, both of these jobs do still function correctly, which makes migration a lot easier. Yeah, go ahead.
So I actually have two questions. One is, do we have a documentation page for actually migrating from the old version to the new one? Like switching to the ID tokens.
Yes, I wrote a tutorial and it's merged now. So after I put the trading together and I understood things a bit better, I wrote this, and this is more of a customer friendly in line with our documentation policies, etc., on how to go about doing it without all the fluff that's in my training.
Perfect. And the second question I thought about, what is there a mechanism that prevents random people from running jobs that they shouldn't? Because I see all these security mechanisms for keeping the password secure, but what's the actual mechanism that prevents me from just running a pipeline and dumping the database?
That is a separate thing. So I mean, you get the benefit of you still have protected branches. So your production secrets are still protected by your access controls on who can merge into protected branches. So you've got this here, and you can set this up however you like, and then you can use merge request, the existing GitLab merge protection and functionality to create access control lists in GitLab to prevent who can write to these branches, which then means you're protecting your CI/CD YAML file against somebody attempting to extract the secrets.
Okay, so in the bound claims, we can specify the permission level required to actually get the secret. like the permission level that's on GitLab, meaning maintainer, developer, owner, etc.
No, I don't think that's in the list. No. But you've got you would have to use the existing repository protections. So if everyone can push the main or whichever your development branch is, then your staging secrets are at risk. But you know, they're staging secrets, they're less important depending on the environment. But here, if you had your actual production jobs limited to a specific set of users, then only root in this instance will be able to merge into auto deploy. So only root would be able to merge a compromised CI job that would extract the secrets. So Vault will protect to a degree, but you need to combine that with sensible protections in GitLab.
Right, that makes sense. Thanks.
Cool. That's just about it, to be honest. The secondary syntax is actually more of a, I've left it as an exercise for people following the training to try and work out. Because you can, as I mentioned, you can specify more than one secret to store in a path, more than one field, and you can rerun the whole exercise with version 2 of the key store, which lets you use a different syntax to access the secret. That is actually covered in the tutorial, as well as in the documentation. So these are the long form for both Secrets Engine version 1 and Secrets Engine version 2. The only real difference between these two is the engine name, just to specify it. But as I mentioned, this is the default. So there is a lot shorter form, substantially shorter form, which is just this. So in this format, what you have in the path, which is the first part of where we wrote the secrets to, the secret container, goes on an at afterwards. And then this is the rest of the path, including the field name, all in one string, whereas in the long form, the field and the path are separate. And you can still specify file false if you want to. In the documentation, it does mention that I am pretty certain that this defaults, the path defaults to ops, because in this example here, they haven't even specified the bit after the at. So if your secrets were stored in a container called ops, you wouldn't need to specify the bit after the at either. You can literally just do the path for the particular secret. So you can condense it down even more if you really wanted to.
No, I'm sorry, I'm somewhat confused. So we have the path towards the actual file, or rather to the actual secret. And the first parameter is that like a bucket that we keep the secrets. But the at and then the field, I'm not understand what the field is.
The field was the item we specified at the end. So let me. So yeah, we put a so we talk to the key value store and we put an item into the key value store. This is a container. So you define this as a key value store. And then after that, you specify the path to the secret. And then we did password equals super secret staging password. So this is the field.
That makes sense.
This is the field part of it. So you can do
So it always needs a key value pair. Like if I wanted to put an SSL certificate, it would need to have the value of the SSL certificate, but the key should also be present.
yes, you would need to specify all of the objects. So
Okay.
if you run vault secrets list as a command, you can see these are all the default types of secret container that come with a default vault install, and we can see there's one called secret, which is a key value store. You can so you can enable a new secret store, a new path. So now we have two. So in this instance, if you were using version 2, you would where this is secret, this would now be new secrets if you'd written into the new secrets path. A bit at the end, or if you were using version 1, it would be the path value.
Right. The shorter syntax is shorter, but it it needs of some understanding of what you're actually doing.
Yeah, it took me a little while to work backwards on it. Yes, I think we're done, unless anyone has any more questions. Cool. Thank you all for coming. Hopefully that's helpful.
Yeah.
That was excellent. Thanks for preparing that. Really well done. Nice preparation. Clearly visible that you prepared well for this. And I mean, on the back of the awesome documentation and training module that you already created. Really good work.
Thank you all for coming.
Yeah, thank you. Lots of learning here.